Okay, we are testing the autonomous mode of our blimp. We have our propeller or gondola set up. Right now it's on a rack. This is so that we can reduce any kind of noise or vibration that would result from actually putting on the blimp, which yields much better results. So we're going to run through a test where we're just going to be wheeling this rack around, simulating movement on the blimp, and showing that the navigation can keep up. So I'm going to start out with calibrating, which is used to just fine-tune the sensors. And then first we'll just see what the drift is. So if you look here on the computer, we're showing these numbers are in centimeters. So far after the 5-10 seconds since I calibrated, it's supposedly drifted 5 centimeters in the Y direction and 6 centimeters in the X direction. So not a very great amount. All right. So I'm going to calibrate again, get clean values. So Cyrus, go ahead and run a circuit. So he's going to go down, so the accelerometers are going to be picking up values at a distance of 5 meters, which we have as these duct tape on the ground. He's going to turn around, which the gyro is going to have to pick up that turning movement and wheel it back. So the total position should be adding up to about 0 or so, and it looks like it over the 5 meters it came out as about 600, and now it's drifting somewhat. Go ahead and run it the opposite direction. Okay, go ahead. So it's at actually, I don't think I calibrated at the right time. Sorry. I think I calibrated when you're still moving it. Okay, here, let go of it. If you calibrate at the wrong time, obviously it'll read in velocities. Okay, go ahead. So we're at 1 meter, 2 meters, 3 meters, 4 meters, 5 meters. Perfect. All right, turn around and come back. 5 meters, 4 meters, 3 meters, or 4 still. So after the 10-meter run, it got down to about a 40% error rate, which is what we've been getting lately. Go ahead and try this in the X direction. But at least the gyroscope is picking up the change in direction, and even though that Y on the board is facing the same way, it is reading it as negative, so it works against itself. Okay, we're good. Go ahead and run that. All right, so X is at 1 meter, 2 meters, 3 meters, 4 meters, 5 meters, 5.5, 6 meters. So again, pretty close to the 5 meters. Coming back. Coming back was slower that time. So it was at, it was about 6 at the 10. So 60% on that one. Go ahead and recalibrate it. Go ahead and run the other direction. All right, 1 meter, 2 meter, 3 meter, 4, 5, 6, 7. And come back. 7, 6, 5, 4, 3, 3.5. Yeah, stabilizing at about 2.5 actually, so that was a good one. So there, the 10-meter run was at 2.5. So navigation is working, not as accurately as we were hoping, but the gyro working in combination with the accelerometers is correctly detecting where the blimp is going and movement patterns just fine. Actually that X leveled off at just 74 centimeters from the origin.
Okay, cool.
So sometimes it works really well, especially when we have it on the rack. But this is just to prove that navigation is up, functional, just not as accurate as we had hoped.